Faster than light, science fiction or future reality. Imagine traveling to the nearest star, Proxima Centauri, not in 4 years but in mere seconds. The vast distances of space, the ultimate frontier, seem to mock our slow pace. But what if we could break the ultimate speed limit, the speed of light? Is faster than light travel just science fiction, or could it someday become science fact? Today, we'll explore the top 5 mind-blowing ways scientists and visionaries believe we might break the ultimate cosmic speed limit. Let's warp into the fascinating world of FTL. Warp drives, riding a wave in space-time. You know, when we talk about space travel, we often think about rockets, fuel, and pushing against something. But what if we could just play with the fabric of space itself? That's the mind-bending idea behind warp drives, a concept that physicist Miguel Alcubierre first proposed back in 1994. Now imagine space-time as a giant rubber sheet. You place a bowling ball, representing a massive object like a star, in the center. The sheet curves around the ball. That's gravity, warping space-time. Now a warp drive wouldn't try to move through this curved space. Instead, it would manipulate the curvature itself. Think of it this way. You create a warp bubble around your spaceship. The space behind you contracts, pulling you along, while the space in front expands, essentially shortening the distance to your destination. The beauty of this idea is that your spaceship itself never actually travels faster than light locally. You're just warping the space around you like surfing a wave in space-time. But of course, there are a few catches. The biggest one? Warp drives seem to require something called exotic matter. We haven't found any evidence of such exotic matter in the universe yet. And then there's the energy problem. Initial calculations suggested that creating a warp bubble would require more energy than the entire observable universe contains. But hey, don't lose hope just yet. More recent research suggests that with some clever tweaking and optimization, we might be able to bring those energy requirements down to something a little more manageable. Wormholes, shortcuts through the cosmos. Let's talk about wormholes, shall we? Remember those shortcuts through space-time, those cosmic tunnels that connect distant points in the universe? The idea has been a staple of science fiction for decades, but what's the real science behind it? Well, it turns out that the concept of wormholes pops right out of Einstein's theory of general relativity. Imagine folding a piece of paper in half. That's essentially what a wormhole does to space-time. It creates a shortcut, allowing you to travel vast distances in an instant. You could theoretically step into a wormhole near Earth and pop out near a black hole millions of light years away. But of course, as with most things in the universe, there are a few complications. The biggest one? Wormholes, as far as we understand them, are incredibly unstable. They have a nasty habit of collapsing faster than you can say quantum singularity. To prop open a wormhole long enough for a spaceship to pass through, you'd need something pretty exotic, something with a repulsive gravitational effect. And guess what? That brings us right back to our old friend, exotic matter, with its negative energy density. Chapter 3: Tachyons, particles born to break the speed limit. Now let's dive into the realm of the truly bizarre, the realm of hypothetical particles that make even the weirdest things in the universe look downright ordinary. I'm talking about tachyons. Imagine a particle that's always moving faster than light, not just sometimes, but always. That's a tachyon. Unlike ordinary particles which gain mass as they approach the speed of light, tachyons would actually lose mass. In fact, if they were to slow down to the speed of light, their mass would become infinite. Talk about a cosmic speed trap. Now here's where things get really strange. Tachyons, if they exist, could have some truly mind-bending properties. For example, they might be able to travel backward in time. Imagine sending a message to your past self using a beam of tachyons. But before you get too excited about building a tachyon time machine, let's be clear. We have absolutely no experimental evidence to suggest that tachyons actually exist. They're purely theoretical at this point. Chapter 4: Light sails and laser propulsion riding beams of light. You know, sometimes the most elegant solutions are the simplest. Take light sails, for example. The idea is remarkably straightforward. Equip a spacecraft with a giant reflective sail and push it through space using the power of light itself. Now you might think, but light has no mass, how can it push something? Well, while photons, the particles that make up light, don't have mass, they do have momentum. And that momentum can be transferred to a reflective surface, like a light sail. Think of it like a sailboat catching the wind, except in this case, the wind is a powerful beam of light, perhaps from a giant laser array here on Earth, or even in orbit around the sun. Projects like Breakthrough Starshot, spearheaded by visionaries like the late Stephen Hawking, are already exploring the potential of light sails to achieve interstellar travel. Their goal? To send a fleet of tiny spacecraft, each equipped with a light sail, to our nearest stellar neighbor, Alpha Centauri, at a fraction the speed of light. Of course, there are challenges. Building a light sail large enough and thin enough is no easy feat. And then there's the issue of generating a laser beam powerful enough to propel a spacecraft across interstellar distances. Chapter 5. Quantum Tunneling. Teleporting through reality's walls. Now, let's journey into the strange and wonderful world of quantum mechanics, where the rules of reality seem to bend and break in the most bizarre ways. And one of the most mind-boggling phenomena in this quantum realm is something called quantum tunneling. Imagine throwing a tennis ball at a wall. In the everyday world, we'd expect the ball to bounce right back. But in the quantum world, there's a tiny chance that the ball could actually pass right through the wall. That's quantum tunneling in a nutshell. Now I know what you're thinking, that's all well and good for tiny particles. But can we scale this up to something a bit larger like, a spaceship? Well, that's the million-dollar question, isn't it? Currently, quantum tunneling is a phenomenon that we've only observed at the subatomic level. Outrow, the future of faster-than-light travel. So, there you have it. 5 mind-blowing possibilities for breaking the cosmic speed limit. Faster-than-light travel remains a dream for now, but history shows us that dreams often inspire breakthroughs. Whether it's bending space-time, opening wormholes, or harnessing quantum mechanics, humanity's quest for the stars is far from over.